Question 11. The nth term of an arithmetic progression AP is defined by t sub n equal to 2n plus 1 over 2. Full stop. Find the sum of the first 10 terms of the AP. Now, let the terms of the AP be t sub 1, t sub 2, t sub 3, t sub 4, and so on. So we need to generate some terms so that we can get the first term and the common difference precisely. So this is the nth term. The first term is when n is equal to 1. You have it in this form. 1 over 2 is the same as 0.5. So the first term is 2.5. The second term, n is equal to 2. If you replace n equal to 2 in the nth term, you have 4.5, and the third term is 6.5 when n is equal to 3, and so on. Note that the first term is 2.5. Common difference is 4.5 minus 2.5. You subtract the second and first term, or the third and second term, and so on. You will have the same 2 as the common difference. This is the sum of terms formula when you have first term and common difference. Sum of the first 10 terms means n is equal to 2. N is equal to 10. You replace n with 10. First term 2.5, n is 10 again. Common difference is 2. When you simplify, you get this result and this. After addition and multiplication, you have 115.0. The correct option is D. Question 12. The fifth and 11th terms of an arithmetic progression are 13 and 31 respectively. Find the sum of its first term and common difference. Always note that whenever the first term and the common difference of an AP are unknown, that question always leads to a system of two linear equations which you solve simultaneously. So this is the nth term formula. At the fifth term, n is 5 and the fifth term is 13. If you replace them in the nth term formula, you have this result. You replace n with 5. Then the fifth term is 13. So 13 is equal to a plus 4d. You can call that equation 1. The 11th term is 31. At that point, n is equal to 11. So t sub 11 is equal to a plus bracket open 11 minus 1 bracket close times d. The 11th term is 31 equal to a plus 10d. You can call that equation 2. Solve both equations simultaneously using elimination method. So you have the two equations rearranged in this form. Let us eliminate variable a because all the conditions required to eliminate a are satisfied. You can see my teachings on simultaneous linear equation in my YouTube channel. Then if you subtract, you have this result. For you to eliminate a, the coefficients need to be the same, and when the signs are the same, you subtract. So when you subtract 13 minus 31, you have minus 18. A minus A is 0. 4D minus plus 10D, you have minus 6D. To get D, divide both sides by minus 6, and D is equal to 3. To get A, you need to substitute D equal to 3 into any of the equations. I'm using equation 1. This is equation 1. You replace D with 3. You simplify to get this result. If you collect like terms, you have this result, and the first term A is equal to 1. Therefore, sum of the first term and common difference equal to 1 plus 3 equal to 4. The correct option is A. Question 13. The sixth term of a geometric progression GP is 486. Find the common ratio if its first term is 2. You use the nth term formula for a GP. From the question, the sixth term is 486. At the sixth term, n is equal to 6. The first term is 2. So t sub 6 is equal to 2 as the first term times the common ratio unknown. That is arrow to the power of 6 minus 1. That simplifies to this. To get arrow power 5, divide both sides by 2, and you have 243. To get arrow, you need to take the fifth root of 243, and that is 3. The correct option is D. Question 14. Evaluate 256 over 81 to the power of minus 3 over 4. Solution. The first challenge is to remove the negative sign from the power. Since you have fraction, if you interchange the position of the numerator and denominator, the power becomes positive. The next thing is to ensure that this 4 is removed. You know, if you factor out 3, what you have remaining is 1 over 4. That is fourth root. So you need power of 4 to remove 1 over 4. You simply express 81 such that the power is 4. The same thing you do to 256. You have it in this form. Power of 4 is common here. You factor it out to have this result. By the time 4 cancel 4, you have 3 over 4 to the power of 3, and that is 27 over 64. The correct option is D. Question 15. Simplify 110011 base 2 times 101 base 2. Solution. What you do is to carry out normal multiplication, which you have in this form. You use the first digit from right to multiply everything here. You have this result. You use the second digit, you have this result. You use the third digit, you have this result. One thing you must note is that the digit you are using, your answer begins under that digit to the left. After the multiplication, the next thing is to add. 1 plus nothing is 1, 1 plus 0 is 1, 0, 0 plus 1 is 1. If you add here, you have 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 1. And here is 1. By this, the correct option is A. Question 16. Simplify 3 over root 3 plus 6. Solution. Rationalize the denominator by using the conjugate of the denominator to multiply both numerator and denominator. The conjugate is simply change in the sign that connects the two terms. So root 3 plus 6 becomes root 3 minus 6. This is the given problem. You multiply numerator and denominator by the conjugate. The numerator is written in this form. You have to expand the denominator. Root 3 times root 3 is 3. Root 3 times minus 9 times minus 6. You have minus 6 root 3. The next thing is to use 6 to multiply root 3. You have plus 6 root 3. Plus 6 times minus 6. You have minus 36. These two terms cancel. You are left with this. If you subtract the denominator, you have it in this form. You divide 3 and 33 by 3. You have this result. This, okay, the numerator over minus 11, you can well factor it out to be minus 1 over 11. Multiply this. If you stop here, the option is not there. So the minus sign, we open the bracket. You have it in this form. You interchange the position of minus root 3 and plus 6. You know, addition is commutative. Minus root 3 plus 6 is the same as plus 6 minus root 3. You have this final result. By this, the correct option is B. Question 17. The value of a car depreciates by 20% at the beginning of each year. If the car costs 1 million naira, find the value of the car after 2 years. So let's take first year. The depreciation is 20% of the cost. That is 20% of 1 million. You express it in this form, and that is 200,000 naira. So amount at the end of first year is the cost 1 million naira minus depreciation amount 200,000, and that gives 800,000 naira. This amount becomes the correct amount at the beginning of second year. So you get the depreciation of that amount, which is this. You express it in this form, and that gives 160,000 naira. Amount at the end of second year is 800,000 minus 160,000. That gives 640,000 naira. The correct option is C. Question 18. Given that matrix A is equal to this and matrix B is equal to this, evaluate AB. That is A times B. For you to multiply any two matrices, you must understand that the number of columns in the first row is in the first matrix is equal to number of rows in the second matrix. That condition is satisfied. So you have AB equal to matrix A times matrix B. To multiply, you take the first row here to multiply first column, first row of the first matrix times first column of the second matrix, corresponding entry to corresponding entry, and you add to the next. The same first row times second column, you have this result. When you are done with that, you shift to the second row and use it to multiply the two columns respectively in this form. If you evaluate here, 2 times 1 is 2, then plus minus is minus. 1 over 3 times 3 is 3 over 3, and that is 1. So you have minus 1. If you evaluate this, you have this result. If you evaluate the second row, you have this result. If you subtract and add, you have the matrix with the entries 1, 2, first row, second row, 15, 30. The correct option is A. Question 19. Find the values of S for which this expression is undefined. Solution. An expression is undefined if its denominator, not numerator, denominator is equated to 0. So this denominator, you equate it to 0. That is S plus 2, S minus 4 equal to 0. You equate each term to 0 in this form. And when you solve for S, S is equal to minus 2 or S is equal to 4. Therefore, S is equal to minus 2 or 4. The correct option is C. Question 20. Find the quadratic equation whose roots are 2 and minus 3 whole number 1 over 2. Solution. The required equation can be obtained using the simple rule below. S squared minus sum of roots times S plus product of roots equal to 0. So let's get sum of roots. You add the two roots together. So you have 2. Plus minus is minus. You convert this mixed fraction to improper fraction. You write this as over 1. If you find the LCM and simplify, you have this, and finally minus 3 over 2. The next thing is to get product of roots. The two roots being multiplied, you have it in this form, and you have minus 7. The equation is S squared minus sum of roots times S plus product of roots equal to 0. Multiply through by 2 to clear fraction. So you have 2s squared. Minus times minus is plus. You multiply this term by 2, you have 3s remaining. Plus times minus is minus. Multiply 7 by 2, you have 14. By this, the correct option is D.